Okay, so now we're going to jump into our next lesson, and our next lesson can be found on page 25, and it goes with the same LEQ that we were working on for the last couple lessons. So the LEQ is how can you write and solve equations and inequalities. Before we get too far, a couple things about video lessons. First of all, video lessons, anything I say, pause, and do those things. Also, if you have a question, please make sure that you raise your hand. Work with others in your group. And feel free to rewind or rewatch any of these videos at home. Okay, so a couple things as we go through. On this one, you won't need it as much, but eventually you'll need a timer and you'll need a task manager. But this one's kind of short. So our LEQ is how can you write and solve equations and inequalities? And right now we're going to talk about another type of equation, or actually two other types of equations that you will see in algebra. So these equations are equations with no solution or infinitely many solutions. So far, you have seen equations with one solution. So you have been able to solve for x and seen equations with those one solution. Now we're going to get into no solution and infinitely many. All right, so that's what we're working on for the next couple of days. So if I take a look at these three equations, 1, 2, 3, and I'm given this set of numbers. So these numbers right here are possible solutions. And I know that they're possible solutions because they're written in the brackets, and algebraically, that's how we show potential solutions. So it says, remember that a solution of an equation with one variable is a value of the with one variable is the value of the variable that makes the equation true. So the set of numbers contains possible solutions to the following equations. Determine which of these numbers are solutions to which of the following equations. So when I go through this, I'm going to go ahead and I'm going to solve A, B, and C. So right now, I want you to pause the video and I want you to work with a partner to figure out which of these solutions go with those potential equations. Once you have it figured out, I want you to hit play and check your answers. Okay, so right now you're pausing, working through those, and hitting play. You shouldn't need a calculator for this. Okay, you should not need a calculator for this. Okay, so for the first one here, it's important to note that none of those possible solutions worked for this. And I guess you could have used a calculator to kind of plug them in and check them. Then for the second one, you should note that the solution 6 worked. And for the third one, you should note that every one of those potential solutions works. So if we go back to our LEQ, identify equations that have no solutions and identify equations with infinitely many solutions. What does the term infinite mean? So infinite means like everything, endless possibilities. So when it says that every solution worked, then you can assume that that would have infinite solutions. So now I want you to go ahead and read this, and I want you to complete number 2. So based on their work, which of these would have one solution, which would have no solution, and which would have infinitely many solutions? And how do you know? So go ahead, read this, and then try to match Laura, Nia, and Leo to which one is which. Then I want you to push play and check your answers. So right now you're pausing and doing the work, and then you'll push play and check the answers. All right, here's what you should have for your answers for number 2. So Laura's equation right here, x has one solution, and that one solution is negative 11/15. For Nia, hers has infinitely many. Going back up to this step right before she got to this, so 2 always equals 2. That's always a true statement. If it's always a true statement, then you can put any value in for x and it remains a true statement. So when we go back up a step before we subtracted out our 3x right there, notice that 3x plus 2 is the exact same expression as 3x plus 2. So if I put 1 in for x there, it copies and it mirrors the same expression there. If I put negative 23 in for x there, it's the exact same expression on the other side. So no matter what I do to substitute in a value for x, they are the exact same expression, so therefore it's always true. And then over here, 6 never equals 17. That is what we call a false statement because 6 is not the same value as 17. So sometimes you'll see this little equal sign with a slash through to show that 6 is not equal to 17. So now if we jump back up here, okay, notice that we have like the same 5x, the same 5x. So no matter what I did, if I substituted in 1, I would have 5 plus 6, which is 11. I would have 5 plus 17, which is 22. So it's never 11 never equals 22. So when I simplify it down, that 6 never equals 17 is always false. Therefore, that last one, Leos, has no solutions. Great. So right now, I want you to go ahead and I want you to add your notes in. You've done one solution equation. So what does it mean for an equation to have one solution? What does it mean for an equation to have no solutions? What does it mean for an equation to have infinitely many? So I want you to provide an explanation. And then I also want you to provide an example for each. Okay, so right now you are going to take what we just did and all that information, and you are going to write your own notes with an explanation and an example for each part of that. Work with your group, and then we will discuss our notes together as a class. Once you finish your notes, I want you to jump down to page 26, and I want you to work on number 3, number 4, and number 5. Once again, determine solutions to each of those equations. And once you are done with this, we will check this as a class as well. Okay, so those 5 things. Please remember, if you have any questions, if you have any questions, raise your hand. Whoops.